The weight of beef used in hamburgers at a certain restaurant is normally distributed, with a mean of 6 ounces and a standard deviation of 0.4 ounces. Let X be the weight of beef in one randomly selected hamburger. Now, question A says, find the probability of X being less than 5 ounces and draw a graph and shade the area corresponding to this probability. Let's begin by drawing a picture. Let's begin with a bell curve. In the middle of this bell curve, at the tallest part, this is where our mean is located. Now the mean of this distribution is 6 ounces, so we'll place a 6 here. Now in this question we are meant to find the probability that the X is less than 5. Now notice that we have a normal distribution because the question says we are normally distributed. Now in a normal distribution, it's different from how you would handle a binomial distribution. This time we don't cross out 5 like you would in a binomial distribution that has the less than sign. Instead, we're going to place a marker where 5 would be on this graph. Now, since we have a fairly small standard deviation, 5 would be fairly far to the left. Now, because we want to go less than 5, we're going to shade to the left side. Notice that the area that I've shaded is fairly small. This also means we can expect the probability to be fairly small as well. Now to find what this probability is, there's some information we need to collect. We'll need to collect the X value that we're trying to test, the mean, and the standard deviation. Based on this, we can find the probability of being less than 5. Now, I'll enter 5 for my X value, because that's what we're trying to test. The mean is 6 ounces, and the standard deviation is 0.4. Now, the formula we use to find probability is norm dist. We'll open a parentheses, and first place the X, then the mean, and then the standard deviation, and then the word true. Anytime we're trying to find area underneath part of a curve, we will use true. And we are trying to find area because the area corresponds to the probability that we are being asked to find. Let's type the formula into the box. Norm.dist, open a parentheses, we click the X first, comma, mean, comma, standard deviation, comma, true. Close the parentheses, and when we press enter, we get indeed a very small probability of 0.00621. For question B, let's draw another picture. Our mean is still 6. But this time we'll draw our mark at 5.5. That's going to be a little bit closer to 6. However, we're being asked to go greater than 5.5 this time. Now, greater means go right. So we will shade in all of the picture that's to the right. Now, again, we have a fairly large area over here, so we could expect a reasonably high probability, something not too far away from 1. Now, this is going to be worked the same way problem A is. We will need the X, we'll need the mean, and the standard deviation. So our X is 5.5, our mean is 6, and our standard deviation is 0.4. Now, we can find, using norm dist, the probability of being less than 5.5. Once again, that formula is norm.dist x mean standard deviation and true. This will give us the probability of being less, and then we can find the probability of being greater by taking 1 minus the probability of being less. So I'm going to make an entry for p less, and after that an entry for p greater. Anytime you're being asked to find the probability of being greater than a number, this will be a necessary step we'll need to add on at the end. First we'll handle p less and do norm dist x mean standard deviation and true. This will give us p less. Now to find p greater, we can say equals 1 subtract and now click where p less is. We've clicked on B12. When we press enter, we get the final answer, p greater, which is 0.89435. For question B, this will be our answer. For question C, we have another variation. Now we are given two numbers, a low number and a high number. Let's draw a picture for this as well. Once again, we have a mean at 6. That's the lowest number we're going to use. We'll mark that in green as well. And then we'll have another marker at 7. We'll shade the area that is in between them. So the area we have is a little bit less than half. We should expect something near 0.5 or a little bit below. Now, if you have two numbers, a low number and a high number, we can do norm dist to both of them. Once again, we'll be entering x, mean, standard deviation, and true for both of them. After that, we're going to take the higher answer minus the lower answer, and this will give us the probability between. So let's make a list. X, mean, standard deviation, and then the probability of being less we'll calculate, and after that the probability of being between. Our first x is 6, and our second x is 7. Our mean for both of them is 6, so we'll put a 6 underneath each one. The standard deviation for both is 0.4. We'll put that as well. Now the probability of being less, we use norm dist to find. We say equals norm dist x, comma, mean, comma, standard deviation, comma, true. Now we can take the black cross and autocomplete that formula, and that pastes the formula into this box, and we press enter, and this will give us the p less for 7. And then the probability between, we'll just say equals the bigger number, the 0.99379, subtract the lower number, 0.5. This gives us a probability of being between those two numbers, between 6 and 7, of 0.49379. That will be our final answer for problem C.